Hey guys, so this is the recording of 3.4, okay? Velocity, acceleration, and other rates of change. Our first vocab is position. Position is a location where the object is at a particular time, and let's use T for time. Okay, our textbook uses S of T to denote position. Okay, other textbooks uses X of T. So if you see either one, make sure you understand that it's talking about position. The next one is displacement. Okay, displacement is the change in position. Okay, the change in position. So that means we're really talking about delta S, right? Since our book uses S of T for position. Or another word is the change, excuse me, in vertical, okay, from time A to B. So what I mean, B should be not too close to that word. To B. Okay, so what I mean is, let's talk about position. Okay, let's kind of sketch it out. So here, let's do a position sketch. Here's time. Obviously, time is not going to have any negative value, so we're just going to start there. And here is the position. Okay, where is it located, right? So at the beginning of time, for example, an object that's moving along the horizontal line, it's, let's just say we're going to start at 0. Then let's just talk about a bike, right? We're riding a bike down along the beach. So at the beginning of time 0, you are going to be at home. The bike's going to be at home. And then maybe like 10 minutes later, you're down on Main Street. So that's where the position is. So the displacement is talking about the change in your position, the change about the bike, okay? So by definition is S of B minus S of A. And yes, very important that you know this formula, okay? Next, we are going to talk about average velocity. Average velocity, again, is not the same as just the velocity, okay? Average velocity, it's, as I put it here in parentheses, is the slope of secant line, okay? So that means it's the change in S divided by the change in time. So the change in S is the change in position, okay? Which is, as you know from above, the change in S is the displacement. Displacement over the change in time. Okay, well, displacement, just like the one above, is really S of B minus S of A all over B minus A. And B and A are the time. Okay, so keep in mind that this is, again, another equation that you would need to know. Now, doesn't that look like just the average rate of change? That's why this one right here said the slope of the secant line. Okay, now velocity. Can you see the word average velocity and velocity are now two different things? Okay, velocity is the slope of a tangent line. Okay, so this really is instantaneous. Oops. Instantaneous. Okay, that means it's going to happen at one location. So we would need to use limit because we do not have a second point. So limit as t approaches some value, okay, S of t minus S of A all over t minus A. So it looks like I'm using limit to the formula as a point, right? Not the formal definition of limit. Or, since you already know how to find the derivative the quick way, you can just do that, right? So s prime of t, which is really saying that the same thing as ds over dt, then that's the same thing as the velocity, okay? So class, the velocity is the same thing as taking the first derivative of the position. Again, velocity is the same thing as taking the derivative of the position. Next, we are going to talk about the approximate the velocity. So approximate velocity is when you pick any A or B values that are close together. Okay, and then that's S of B minus S of A all over B minus A. So if a question asks you to approximate the velocity, then you're kind of just guessing the slope. Let's talk about the speed. Hi, honey. You want to say hi?
Hi.
Okay. We'll do speed. Okay, so speed, the difference between speed and velocity is that speed does not take into account direction. That's the difference between speed and velocity, okay? It can only be positive. So the speed can never ever be negative. Velocity can be negative. Speed can never ever be negative. So speed is exactly the same as velocity, except, okay? Except that it needs to be an absolute value of velocity because speed cannot be negative. And remember, v of t is the same thing as the first derivative of your position, okay? How important is this? Super important. Okay, next, acceleration. Acceleration is we're going to use a of t, which is, guess what? It's going to be the first derivative of the velocity. Well, the velocity is already the first derivative of the position, so it's really the second derivative of position. That's how they are related, right? Okay, so now we're going to go over here and kind of put it all together in one big picture. Summary of relationship between position, velocity, and acceleration. Okay, so let's start with the first one, position. Position. I'm going to give you s of t, okay? But the next one we're going to have is velocity. Velocity. Well, velocity is v of t. How is that related to position? It's really the first derivative of position. Now, what if we are talking about the object is moving in the positive direction, okay? Then object moving in the positive direction. Okay. If a question is asking when is the object moving into the positive direction, that means your velocity is greater than 0. Okay, then it's also going to ask you object moving in the negative direction. This is when your velocity is less than 0. Then it sometimes asks you when is the object stops or changes direction. Stop or changes directions. That means when the velocity is exactly at 0. Okay, so that's what you need to know about velocity. And the next one is going to be acceleration. Acceleration. Now, how is that related to speed and velocity? Okay, so acceleration is a of t. which is the first derivative of v of t, which is really now the second derivative of s of t. Okay, so that's acceleration. Now, let's talk about what happens when the a of t is greater than 0. Okay, so when a of t is greater than 0, that means the accelerating force is to the right. So accelerating force is to the right. Okay, that means when a of t is greater than 0. Okay, so what happened when a of t is less than 0? A of t is less than 0. That means its accelerating force is to the left. And what happens when a of t is exactly 0? No, it's not stopping. It just said that the velocity is constant. Okay, a of t is equal to 0. It means the velocity is constant. Okay, all right, and this is the end of our definition.
Hey guys, here's example 1 from 3.4. A particle moves along a line so that its position at any time when time is at least 0 is given by the function s of t equals t squared minus 3t plus 2, where s is measured in meters and t is measured in seconds. Part A. Find the displacement during the first 5 seconds. So displacement is s of b minus s of a. Well, we know the first 5 seconds, meaning that we end at 5 and we start at 0. So s of b is 5 minus s of 0, which is a, equals, I plug it in. Here we go. 1 minus the other equals. S of b, time is 5 seconds, 5 squared minus 3 times 5 plus 2. Over here, when s is 0, everything cancels except 2. That's 25 minus 15 plus 2 minus 2. Those two are canceling, so 10. So the displacement during the first 5 seconds will be 10 meters. Okay, so the displacement during the first 5 seconds will be 10 meters. B, find the average velocity during the first 5 seconds. Average is delta s, divided by delta time. Well, that's really mean the time, the difference in position, which is s of b minus s of a, all over your t2, so that's 5. Oh, what happened? 5 minus 0, because b was 5 and s of a is s of 0. Well, we found that this is pretty much then the displacement. Okay, s of b minus f of a. This is just the displacement divided by 5. We found the displacement from the top, which is 10 divided by 5. So the average velocity during the first 5 seconds is 2 meters per second. Okay. Find the instantaneous velocity at time equals to 4. Instantaneous meaning that we have the velocity. Instantaneous rate of change is now the derivative of your position. So which means the velocity. The derivative of the position is, your original was t squared minus 3t plus t. Based on the power rule is 2t minus 3. We're looking for at time equals to 4. That's 2 times 4 minus 3. So this is 5 meters per second is the velocity at t equals to 4. D, at what values of t does the particle change direction? And based on your notes vocab before, it changes direction when the velocity equals to 0. Velocity, it is right here. Okay, so velocity equals to 0. That means 0 equals 2t minus 3. So solve for t. T comes out to be a positive 3 over 2. So the particle changes direction at 1.5 seconds, or you can write 3 over 2 seconds. Either one's fine by me. E, where is the particle when S is a minimum? Okay, S is talking about the position. Minimum, remember, the position was given to you. Let me move it. Oh, it's frozen. Okay, the position was given to you as in, and it's, oh, there you go. The position was given to you in terms of t squared minus 3t plus 2. So that's a parabola. It's an opening up parabola. So a minimum is really down here at the vertex. Well, the vertex is when the slope is 0. Well, the slope is 0 is when the velocity is 0. And we found the time when the velocity was 0 at t equals to 3 over 2. So it says where, okay? Not when. When, that means the time. It's looking for where. So we will plug in the time. So the position is 0. It's at the minimum at the time of 3 over 2. Excuse me. So I will plug in 3 over 2 to your position formula, which is t squared, which is 3 over 2 t squared, minus 3 times 3 over 2, take away, I'm sorry, not take away, plus 2. So that will give me 9 over 4 plus 9, minus 9 over 2 plus 2. That will give me a negative quarter. So what does that mean? It means, I'm going to write it out for us. When S is a minimum, the particle will be at meters. So the particle will go lowest. In this case, I can't really say lowest, wouldn't even be right, because it's going left to right. Will go as far left as negative 1/4. Okay. Now technically you can stop right here if you need to. If you have physics and you understand all of the particle stuff. If you don't, this is just sort of a side explanation of what all of this means. So you were given, let's go back here really quickly. You were given a particle and it says it goes horizontally, okay, moves along a line. So a line is really talk about horizontal. So here's your displacement. This is your S. Then it said this is in terms of time. So we'll 2, 1, 0, negative 1, and negative 2. We'll go to 3, 4, and so on. So this is where the object is at. This is moving along a number line. Well, if I were to make a table, it will give you a better understanding. So S of t equals t squared minus 3 times t plus 2. And again, if you understand all of this already, you don't need to listen to this any further. So at time equals to 0, because it said time has to start at 0 or bigger, because time can't be negative here. So when I plug it in, the object starts at 0. So on my position, the object starts at 2. At time equals to 0, the object starts at 2. Okay. If I keep on going, okay, so I'm going to go pick my green pen back. 1 second later, I'm going to plug it in. 1 squared minus 3 times 1 plus 2. That's going to be negative 2 plus 2. That would be 0. Okay, 1 second later, I'm going here. So I'm currently at, wait, not there, at 0. My bad, I just wrote 0. Okay. A second later, so what that means is I'm really going left. Okay, again. 1 second later, I'm currently at 0 on my number line. That means I'm going left. Well, technically, I should really put in 2 seconds later. But remember, when we did this down here, we said it turned around, the object turned around at 1.5 seconds. Okay, what does that mean by turn around? It turns around means I originally started going left. It turned around here. So if I plug in 3 over 2, 3 over 2 quantity square minus 3 times 3 over 2 plus 2. And we did this math right here already, okay? This right here said it came out to be a negative quarter. So at 1.5 seconds, okay, at 1.5 seconds, that means I'm here, a negative quarter. I'm still going left, okay? So at 1.5 seconds, the position is negative quarter. Well, let's see if it's really true. If we plug in time equals 2 and it gives us a value that's bigger than a negative quarter, then we knew for sure that it did turn around. So 2 squared minus 3 times 2 plus 2 equals 4 minus 6 plus 2. Oh yeah, that's definitely bigger than a quarter. So 2 seconds later, get a different color. Let's get blue. 2 seconds later, I'm back at a position of 0. So look, I'm really turning around. What if I pick 3? 3 squared minus 3 times 3 plus 2. So this is going to be 2. Wow, 3 seconds later, I'm actually here where I started. So 3 seconds. It took me 3 seconds to go back to where it was started. What if I pick 4, 5, 6, 10 seconds later? Is it ever going to go to the left again? So when I pick 10 squared minus 3 times 10 plus 2, so this is really 100 minus 30 plus 2, so 72. So 10 seconds later, I'm like all the way over here, which my number line doesn't hold. So as you can see, it went left, okay? It started out going left until 1.5. And then it went right indefinitely. Okay, so this is really what's going on with this object. I know, it's really cool, right? We'll touch more on that later. But right now, that's what all of that connection is. All right? The position of a body at time t is s equals t to the third minus 6t squared plus 9t meters. Okay, so this m right here means the unit of measurement. In this case is meters. Find the body's acceleration each time the velocity is 0. Okay, so let's talk about acceleration. It says find the body's acceleration. So acceleration with respect to time is the same as the first derivative of the velocity, which is the same as the second derivative of the position formula. So we have the position right here. So what we might want to do is find s prime of t to give us the velocity. So that's 3t squared minus 6 times 2t, okay? Because 6 is the constant. You can pull it out, make it weight, and just take the derivative of t squared. And the derivative of 9t is just 9. So now s prime of t is 3t squared minus 12t plus 9. But what is it that I want? Okay, I eventually have to do second derivative, but let's talk about this question. Find the body's acceleration each time the velocity is 0. Well, this is already the velocity, right? Because it's the first derivative of the position. So I have to take that and set it equal to 0. So 3t squared minus 12t plus 9 equals 0. Let's try to factor out a 3 to make it smaller so we don't have to work with such ginormous numbers. So t squared minus 4t plus 3 equals 0. So divide both sides by 3. 0 divided by 3 is 0. So technically we only have this left to factor. So we have t minus 3 and t minus 1 equals 0. So t equals to 3. So at 3 seconds and at 1 second later, okay? So the velocity is 0 at those time frame, okay? So velocity is well, that doesn't look like an S, okay, I was gonna merge the S and the 0 together, and as you can see, it didn't work out so well, okay, is 0 at 1 and 3 seconds, okay? All right, but I'm really not interested in that right now. I'm interested in the acceleration when it is at 0. So I need to take the second derivative. So here we go. Second derivative of position is, I'm going to use this equation right here. okay? So that's 3t squared. The derivative of 3t squared is going to be 6t. And then the derivative of negative 12t is just simply negative 12. So now this is acceleration, okay, with respect to time. Well, it says find the body's acceleration each time the velocity is 0. Well, the velocity is 0 at 2 locations, so I have to find both. So a of t, in this one, let's use 1 first, okay? So a of 1. A of 1 is so this is the seconds, okay? So the first time the velocity of 0 is 1, so I'm going to plug 1 in. So 6 times 1 minus 12 equals 6 minus 12, which is going to be negative 6. And then because this is acceleration, we might have to write the correct unit of measurement, so make sure we have it as seconds squared, okay? Then you can do the second time, which is at 3 seconds, so plug it in. So you can do 6 of 3 minus 12 equals 18 minus 12, so that's positive 6 seconds, 6 meters for second square, okay? So what does it mean by negative acceleration? Okay, so two things with negative acceleration, because you can see there's a positive and negative answer. So negative acceleration. Oh, it's okay. You don't have to. You can pull it all the way up. Yeah. Sorry, just talking to one of my students. Negative acceleration can mean two things, right? So it can slow down, or it's slowing down, and it's speeding in the opposite direction, okay? Speeding in the opposite direction. Okay, so how would I write the final answer? Here we go. The object is accelerating at, the object is accelerating at t equals 3 seconds. I'm sorry, I should use the don't erase. Sorry, at 3 seconds, it's at what, 6 meters per second? The object is accelerating at 6 meters per second square at 3 seconds. There's a lot of at, isn't it? That sounds confusing. The object is accelerating at 6 meters per second square at 3 seconds. Okay, and negative 6 meters per second squared at t equals 1. There's just a lot of at in there, so that sounds really confusing. Okay, so I'm going to read that one more time to see if it makes sense. The object is accelerating at 6 meters per second square at 3 seconds, and negative 6 meters per second square at t equals 1. Okay, so that sounds okay. All right, next one. Example 3. A particle P moves on the number line shown in part A of the accompanying figure. Part B shows the position of P as a function of time t. So let's look at the two parts, okay? And since I didn't label A and B, let's do A and B. Here's supposed to be your part A, and here is your part B. Okay, so this is part A. It's the particle moves on the number line. So that's why we have a number line. Okay, it's moving back and forth, back and forth. And part B shows the position of P as the function of time t. So B is shown how high it is as time goes on. Okay, so letter A. When is P moving to the left, and when is P moving to the right, and when is it standing still? So let's talk about left, right, and standing still, okay? Under your summary, we have written down left and right and standing still, okay? So left is when v of t, the velocity, is less than 0. Moving right is when the velocity is greater than 0. Standing still or about to change direction, okay, standing or stopping is when v of t is at 0. So let's look at our position, because if I take the derivative of it, then I would have all of the answers. So the derivative of position. So this is s of t because it says position, okay? So let's look at the derivative. So it looks like issues are, we have some funky looking thing right there, and right there, and right there, and right there, and right there. Would you agree? So all of those spots are pretty much weird things that we have to look out for. So what's going on? What's happening with the slope or the derivative at all of those red marks? So I want you to think for a second, okay? What's the derivative of all of those red circles? Would you agree that the derivative is not defined? Okay. So let's start with left, okay? Left. Left is I'm looking for the derivative being negative. So I'm looking for the slope of the position being negative. So the slope of the slope is negative. So first slope I see that's negative is right here. Okay, so that's this negative slope right there. So that time, this is 0, this is 1, this is 2, this is 3, that's 4, this is 5, this is 6, this is 7, this is 8. Okay, so would you agree that is negative from 6 to 7? Okay, so left from 6 to 7. Because this is undefined, so I can't use it. So I can't just say, oh, you know what? It's turning left continuously from 6 all the way infinitely. Well, that's really not true. Well, let's keep this. How about make it 9 and make it 10? Add on 2 more tick marks, okay? And make it n. So we are going to go, hey, you know what? Let's make that from, there's some undefined values at 7. So 7 all the way to 10. So that's your left. Okay. Then let's do right. Right means I should have a slope that's positive. So positive slope is right here and right there, okay? So we will have right is from 0 all the way to, let's make this what, 1.5? Okay, so that's right 1.5, union that with, this is 3 to, what do you want to make this, like 4.5? Okay, so let's make that 4.5. Just stay on the same track here. So that's when the object is moving to the right. Now, when is it standing still? So standing still, let me use a different color. Okay, so standing still. Okay, keep in mind standing still is when the velocity is 0. That means the slope is 0. So the slope is 0. It's right there. Can you see that? And right there. Okay, so standing still, I have it at 2 places. It's going to be from 1.5 all the way to 3, union that with from 4.5 all the way to 6. Okay, so that's all of the spots that it's going to have a slope of negative slope, positive slope, or when it is 0. Okay. All right. Part B. Graph the particle's velocity and speed were defined. So I'm going to do 2, velocity and speed. Okay, so let's do velocity over here. So this is time, and this is v of t. So I'm really pretty much graphing S prime. And this is speed. Can you tell me the difference between velocity and speed? Do you recall what the difference is between the two? I'm gonna change this to make it lower. Can you tell me the difference is between the two? What's the difference between velocity and speed? The speed is an absolute value of velocity, so it's only positive. That's why I'm making this slightly bigger on the y-axis, where it's more positive. All right, so I have 0 to 10 seconds, so let me do those marks, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Then I'm gonna give you a second to give it a chance. I want you to try it out, and then I'll come back and kind of fill in the gap if needed. Okay. So I'll put like a minute on the clock. Were you able to figure anything out? I'm gonna go in and put some tick marks in here. Okay, so if you did it, or if you were trying and wasn't very successful, let's work it out together. Okay, so this is right here, as you can see, 1, 2, 3, 4. Okay, so this point is 1.5 comma 3, and this right here is 0, 0. So what I'm gonna do is I'm gonna try to find the slope for that, okay? From 0 to 1.5. So the slope for that is just really what? The delta y divided by the delta x. So it's gonna be 3, which is y minus 0, all over 1.5 minus 0. So that's really 3 divided by 3/2, right? Which is really 3 times 2 over 3. So the slope of that is 2. So what are you going to do with that slope? I'm going to go in and plug it in. From 0 to 1.5, I have a slope at 2. So the slope is defined at, assuming that this is a closed dot. So we're going to assume right now it's a closed dot because it didn't say. And then it's defined from 0 to 1.5. So that's my slope. Then the slope from 1.5 to, looks like 3 is 0. So that's open circle, 1.5 to 3. So that slope right here is 0. Okay. Then this slope, I would have to figure out what that is. Okay, so let's figure out. This is 4.5 comma what? 1, 2, 3, 4, 5. So 4.5 comma 5. And this point right here is 3 comma 3. So let's find the slope for that, okay? I need space for scratch work. So if you have space for scratch work, write it somewhere so that's not going to be confusing for you to look back later. So I'm going to use delta y, so 5 minus 3 divided by 4.5 minus 1.5. So that's really 2 over 4.5 minus 1.5, that's 3, so 2/3, okay? So positive, almost 1. So that's from what? 3 to 4.5, so 1, 2, 3, so almost 1, open circle. 1, 2, 3, 4, 4.5 is right here, open circle. So that's the velocity. So right now, most of this is 0 or positive, which we understood because it was going to the right, right? Okay, and then let's look, this is also 0 right there. Can you see that? So from 4.5 to 5 is that 4.5 to 5 or is that 4.5 to Yeah, 4.5 to 6, my bad. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4. Oh, did I? Oh, let me see my x value here. Did I like sketch this one wrong? Okay, 4 from 3 to 4.5. 1, 2, 3, 4. That's 4.5. Let me number these. I'm like confusing myself. 1, 2, 3, 4, 5. Okay, so 4.5 is okay. From 4.5 to 6. 1, 2, 3, 4, 5, 6. Yep, 6. Okay. The slope is 0. Okay. I don't have it numbered, so I'm like totally confused by it. Okay. So now let's look at this next piece right here. Okay, let's figure out the slope. Actually, that one's a nice one. I can count. Down 2, right 1, so the slope is just going to be -2. So down 2, right 1, so the slope is -2. So from 6 to 7, the slope is -2. Okay. All right, last piece. Here we go, from 7 to 10. So let's use this one. 7 to 10. What is the slope? Okay. So this is 7, 1, 2, 3, 7, 3, and this is 10, 1. So what is that slope? 1 minus 3 divided by 10 minus 7. That's -2 over 3. So -2/3. So this is 7, this is 8, this is 9, this is 10. Okay. So it is from 7 to 10. It's negative and is close to -1. So here to all the way here. I just have to be careful because okay, the slope is -2/3. Okay, so there you go. So that's the graph of the velocity. And I just have to be really careful. There's a lot of basic math, and I tend to get my basic numbers incorrect from time to time. Okay, so now let's do the speed. The speed is nice because all I need to look at is the velocity work, and I've already done all the hard work. All the basic math is done, and remember, that's the part that I always get wrong. So, but I do need to number these because that was the part that was kind of confusing for me. Okay, and then I'm gonna go up to 1, 2, 3, 4. If it's not labeled, then I'm assuming it's by ones. Okay. Okay. Well, look at this. The first bar is already positive, so I don't even have to do any work. Oh, you know what? Put closed circle here because the last one, because we are gonna assume that's closed circle on the position, so it's gonna be defined right there. So the left-hand derivative is going to be okay. All right, so the first one is going to be exactly the same as the velocity because it's already defined. The second one, it's okay to have speed of 0. So that's okay to have right there. The third one looks like, I remember it was 2/3, right? So I'm going to go up to here. 4.5 is here. And the next one, the fourth one, again, is back at 0. So the only difference is right now we only have 0 and positive. So that's why all of this is still here. Now the next one, I remember the slope was a -2, but I can't have -2. So I have to bring it back up to here. And that was 6 to 7. Okay. So if it's a negative slope, so we have to bring it back to the positive side because it's an absolute value. Okay. And then same thing, that was a -2/3 from 7 to 10, and this is closed circle, okay? Then we're gonna go that way. So bring that back to the top. See right there? That's the only difference between velocity and speed, okay? Okay, now if I'm going too fast, please do tell somebody to hit pause, okay? Example 4. The accompanying figure shows the velocity. Oh, so this is S prime. Oh my goodness. Okay. V of t. Shows the velocity V equal to F of t of a particle moving on a coordinate plane, a coordinate line. When does the particle move forward? When does the particle move forward? So keep in mind that moving forward or moving right is when the velocity is positive. When does it move backward? Move backwards is when the velocity is negative, okay? So this is already velocity. So would you agree the velocity starts at 0, assuming these are like closed dots, okay? And it's positive from all the way there. Whoa, and this is like 30, okay? So moving forward, okay, it starts at 0, so I guess at 0 technically we're not going anywhere yet, right? We're just starting. So 0 all the way to 30, okay? Then it's going backwards, okay? Backward is starting at 30. So 30 is where it's 0, and that's where it's about to change direction. So it's not going anywhere, it's holding still, okay? All the way to, this is negative right here. Woo, right there, and that's 50, so that's 55, okay? So 30 to 55. When is the particle's acceleration positive? And when is it negative? And when is it 0? Okay, so let's talk about, if you remember, how do I know if the acceleration is positive? So, positive acceleration, meaning that the v prime is, because keep in mind a of t equals v prime, so it has to be what? Positive or negative? Positive, right? Okay. And then when do you think it needs to be, when is the negative acceleration? When a of t is less than 0. And when it's 0, then when it is 0, okay? When the derivative is 0. So let's look at the positive. So this is v of t. So if I take the derivative of v of t, that will give me acceleration, a of t. So from here to here, it looks like that is a positive, right? These are the undefined spots. Would you agree? Okay. So I have a positive slope from 0. So positive from 0 all the way to 10. Is that the only one that's positive? How about here? Could we say that this is positive? Down here in the bottom? Yeah, for sure. That is also positive, right? That's positive from 40 to 55, okay? So it's positive acceleration from 0 to 10 and 40 to 55. Negative acceleration is when the derivative, the slope is negative. So let's look at a couple of negative. Would you agree? It's negative from here all over here straight through. Okay, so how should we write that? So negative, okay, from, looks like this is what is that right there? 15? 15 all the way to 40, right? So that's negative slope. Then 0 acceleration. When is the 0 acceleration? When the slope is 0, right? So here, from here to here. So that's what, 10 to 15? So that's 10 to 15, okay? So positive acceleration is really, you are looking at the positive slope for velocity. The negative acceleration is you're looking at negative slope for the velocity or from the velocity graph. Then 0 means you're looking where the slope is 0 from the velocity graph. When does the particle move at its greatest speed? When does the particle move at its greatest speed? Well, think about this. Speed is the same as velocity, except it always has to be positive. So if you look at the negative velocity here, the largest number is negative 40. If you look at the number up here, the largest number is 60. So the greatest speed is, so you just have to look at the highest number on the y, right? So the highest number is 60 miles per minute, right? 60 miles or meters. It doesn't say m, so I'm assuming that's miles, meters per minute, okay? And if you really want to get fancy, we can even put the time, okay? When does a particle move at its greatest speed? The greatest speed is 60 meters per minute at, when means we're looking for time. So that's from 10 to 15, from 10 to 15 seconds, how about that? From 10 to 15 seconds, okay? From 10 to 15 seconds. Or minute, I'm sorry, this unit is minute. That's a long time, okay? So when means I'm really looking for time, okay? When does a particle move at its greatest speed? The greatest speed is 60 meters per minute from 10 to 15 minutes. When is the particle speeding up and when is it slowing down? Okay, so let's talk about speeding up and slowing down. We have not mentioned this. So speeding up, okay? I'm spelling everything out. Speeding up means both a of t and v of t have the same sign. What does that mean? That means they're both positive or they're both negative, okay? So both positive or both negative. Slowing down okay, means a of t and v of t have opposite signs, okay? All right, so one's positive, one's negative, vice versa. So let's talk about when is it slowing. Let's do, well, I wrote speeding up first. I guess let's do speeding up first, okay? Speeding up. Okay. So would you agree from here to here, velocity is positive because it's above the y-axis. And the slope is also positive because it's going in the positive direction. So that first piece right there would constitute speeding up, okay? So from 0 to 10. And then what's happening right here is that this is the slope of 0. And earlier we said the slope of 0, it's not, right? We are doing what at the slope of 0? We're not doing anything, right? The slope of 0, we're changing direction. V of t is 0, is changing direction. Well, another spot, okay, so look at this piece. Even though this is above the velocity, oh, different color. Okay, so this piece right here, see that right there? That piece has negative slope, but the velocity is positive because it's above the y-axis. So that's opposite sign. So that is really my slowing down. Okay, slowing down. Okay, so that is from 15 to 30. Then let's look at the next piece. Okay, how about this one? This piece right here is velocity is negative because it's below the y-axis, and acceleration is negative because the slope is negative. So that piece right there is actually speeding up because the signs are the same, okay? So that's actually speeding up, and that is from 30 to 40. Okay, Then let's look at the following piece, like this piece. That piece, the velocity is negative because that is below the y-axis, but the acceleration is positive because the slope is positive. So because that is opposite sign, I'm going to say that is slowing down. So that's from 40 to 55, okay? So that's how we constitute speeding up or slowing down. All right, I think this is enough notes for one day.